Hello everyone, my name is Febi Chajadi and I am a master's student at the University of Saskatchewan. In this video, I will be talking about visual distinctiveness in icons and how they affect a user's ability to learn them. Here's an overview of what we're going to be covering today. First, we'll go over learnability in icons and why visual variables matter in this context. I will briefly talk about our methods and the system we built to conduct the study with. Then, I'll cover the study we did to evaluate the effect of visual distinctiveness on icons. And finally, we will conclude with a summary of our results and the takeaways of the study. Learnability is important in graphical user interfaces because it is an important part of a user's transition from novice to expert. Many kinds of learning can occur with an interface, but for WIMP interfaces, one main way that users improve their performance is by learning the commands associated with icons in toolbars and ribbons, and where those icons are located. Therefore, a goal in the visual design of icons is to help the user remember the icon and the underlying command. However, other goals in icon design may interfere with an icon's ability to communicate its intended meaning to the user. One of these goals is the desire for visual consistency and cohesiveness, the idea that all of the icons in an interface should repeat the same visual variables such as color, contrast, weight, shape, angle, or size in order to tie together the visual elements of the interface and give the system a recognizable style. It seems likely that icon learnability could be affected by the visual attributes of the icons. The issue has been raised by some users who have noticed the potential problems of flat icon design. Recently, Microsoft has moved away from flat icons to more colorful and non-uniform imagery reminiscent of earlier guidance on graphical design. Previous research into visual variables suggests an increase in both noticeability and memorability when multimedia objects employ variations in color and shapes. However, there are limits to how shape may contribute to better learnability. For example, an icon that cannot clearly represent its command may cause confusion and impede learning despite the benefits of using representative icons. Designers need to know whether the visual properties of icons can affect learnability and memorability. Although there's information about the usability of certain visual properties, there is little known about effects on learning. To address this gap, we conducted 2 user studies to investigate the effects of visual distinctiveness of icons on learnability. We manipulated 2 visual variables, shape and color, but because the shape of an icon can also be representational, we also consider the cognitive variable of meaning in our studies as well. We developed 5 custom web-based desktop icon selection interfaces, each consisting of 60 icons presented in a standard ribbon toolbar structure. All icon toolbars appeared at the top of the interface and allowed 2 types of mouse-based interaction, selection and hover. Icons were created using the GIMP image editor, using source images from freely available icon sets, such as Material.io and Icons 8. Participants were asked to select icons based on corresponding word cues. In each of our 2 studies, 20 participants were recruited from the local university. In our first study, we tested the effects of meaningfulness in the icon's representation by comparing abstract and concrete imagery, and the effects of color by comparing monochrome icons to icons of different colors. We also tested a 5th icon set that had substantial variation in both shape and color. We found that icons with concrete imagery were learned much faster than abstract icons. Adding color to either the concrete or the abstract icon set did not lead to improved learning. and varying both shape and color did not improve learnability in icon sets that are already distinctive in color, nor against an icon set with only distinctive shapes. In our second study, we assessed meaningfulness using icons that were either identical squares or concrete images, familiarity using concrete icons that were either unfamiliar shapes or familiar images, and color, where square icons could be either monochrome or colored. Our results suggest the addition of color to the identical gray squares did not improve learning. Unfamiliar shapes, that is, Chinese characters for users with no familiarity with them, were much harder to learn than familiar shapes, such as everyday objects, and that there was no difference in learning between the Chinese characters and the gray squares, even though the characters were far more differentiable in terms of shape. We theorize that color's ineffectiveness may be due to the color cues interfering with one another, reducing the value of color as a landmark. Remembering only that an icon was beside the blue one did not uniquely identify a target because there were several blue icons. There may have also been an issue for shapes without meaning too. Namely, interference between similar looking shapes may have prevented a shape's differentiability from being useful as a landmark. However, color and shape may still be useful as a landmark if there are fewer shapes that have more noticeable differences. One of the future directions this work can take is to test the idea mentioned that color and shape differentiability could be more effective if there are fewer items in the set that are different, thus providing a better anchor for spatial learning. A possible implementation would involve strategically placed icons that are designed to catch the user's attention using color or shape within the toolbar to see whether these icons could anchor memory and potentially improve learning. Another future direction this work can take is to test retention after a time period, or to test transfer from the training task back to a real-world task with the interface. The takeaways are that color did not improve learning in either study, nor did using multiple distinctive variables improve learning. Shape distinctiveness, in conjunction with meaning, had substantially improved completion time and hover amount, while shape distinctiveness on its own did not. In our observation and interviews with participants, we found that participants often search by meaning rather than visual characteristics. In summary, our results showed that our manipulations of these variables did not have significant effects on learning or performance, and that the concreteness and meaning of the icon's imagery was far more effective in helping users learn and recall targets. Our studies provide new empirical evidence for existing guidelines that suggest an icon that is contextual or familiar will be more learnable and easier to navigate. This work increases understanding of how users learn new icons and the relative roles that visual variables and cognitive factors play in users' spatial learning and expertise development. Thank you so much for watching.